In this lesson, we will learn the concept of filtering. How do layer 2 switches filter frames? Now, filtering of frames is also known as dropping of frames. Those both words or terminologies are synonymous. So we'll use those interchangeably. Up until now, we have learned that when a switch receives a frame, the step one is to learn the MAC address and populate the MAC table. And then the second step is where the switch either forwards the frame or floods the frame. Now with filtering, we will be adding the third choice that the switch will have. And filtering, it will check if the source and the destination address of the frame are on the same port, then it will drop the frame. And by filtering or dropping the frame, it avoids unnecessary flooding or forwarding of frames. Let us connect a hub to our switch. So this is our topology, switch S1 with 4 ports, P1, P2, P3, P4, and PC1 is connected with PC1 with MAC address A is connected on port P1, PC2 with MAC address B is connected to port P2, PC3 with MAC address C is connected to port P3. Next, we will connect a hub to switch P4 port like this. So P4 port of switch is connected to port P1 of the hub. And then we have PC4 with MAC address D connected to port P2 of hub, PC5 with MAC address E connected to port P4 of hub, and likewise PC6 with MAC address F connected to P3. And then the switch has a MAC table, which is initially empty. And this is where we are going to start our discussion with, right? Starting with an empty MAC table. So let's say PC4 wants to send data to PC6, creates a frame where DA is equal to F, SA is equal to D, sends it out. Hub receives it. Hub being a dumb device, floods it. All the 3 ports. The copy of frame reaches PC5, PC6, and the switch. On the switch, it arrives on port P4. Let us one by one analyze how will PC5, PC6, and switch interpreted. Okay, switch 6 checks the DA value. Find it to be F, matches, compares it with own MAC address, which is also F. It matches, so it accepts it. Good. PC5 also goes through the same process, checks DA value, matches it with its own. DA value is F, its own MAC address E. They do not match, and hence the frame gets dropped. Next, switch. Again, remember, switch has no clue where it is receiving the frame. All it cares is it has received the frame on port P4. It goes through its analysis process. First step, check the SA field. Value is D. Okay. It does not find D in the MAC table. Checks for the corresponding port P4. Find it to be P4, hence make an entry. D is reachable via port P4. That's the key point. Again, let me repeat. Why we build MAC table is to make forwarding and flooding decisions. This is what we have learned till now. Well, if a PC1 has to send a frame to for MAC address D, it will be forwarded on P4. Likewise, PC2 or PC3 have sent it to port, send it to MAC address D, it will be sent out of port P4. So that's what the key logic that we have learned till now. Okay, all good so far. So second thing, what it does is after learning, okay, here source address is D, made it. Next thing is checks the value destination MAC address for F. It is not in the MAC table, hence it floods it. for port P1, P2, P3. All the three PCs receive it, check the destination address value. It does not match their own MAC address, hence all three of them will drop them. Okay, good. So up until now, nothing new we have learned, right? Everything what we've learned is covered in the previous lectures. But this is the foundation we'll need to build on the aging concept. Okay, so next step. Let's say PC5 wants to send data to PC4. Creates a frame. DA is equal to D, SA is equal to E, send it out. The hub receives that, hub floods it. Okay, let's analyze these. PC4, PC6, and port P4 of the switch S1 receive it. PC4 will accept the frame as the DA matches its own MAC address. PC6 will reject it because DA value of DA does not match its own. Here DA is equal to D and PC6 MAC address is F, so it rejects it or drops it. Next, let's see how switch 1 deals with this. And this is where the the aging concept is going to be clear now. Okay, so again, switch 1 does not know where the frame is received from. It goes through it analysis process. Step 1, check the source address field of the frame. Source address field value is E. Check if MAC table has an E in there or not. It does not have E. So it is going to create an entry E. But before creating an entry, it checks what is the port on which it received, port P4. So learn that E resides on what? Port P4. Okay. Done. So far, so good. Next, S1 checks the value of DA field and finds it to be D. Next, check if the MAC table, if it has the entry for D, it finds it to be D. Great. Okay. But the unique situation is that the frame is received on port P4, which is good. All right. And now the destination is also on P4. So obviously we are not going to forward the frame to P1, P2, or P3. Now the question is, does it make sense for us to send the frame back on port P4? Right? Doesn't make sense because when it is coming from this direction, why would we want it sent back? So here the switch assumes that there is no point of sending it back or forwarding or flooding it to these ports. So don't send it back to P4 because it is received on there. It should already have reached the destination. So what it does is simply it doesn't forward the frame or flood the frame. It simply drops the frame. This process of dropping the frame is called as filtering. It does not send out the frame here or here, and it does not make a U-turn and send it back. It just filters the frame. Any frame with destination MAC address D that arrives on port P4, it will just drop it and filter. Drop it or filter it. Okay, that's how the switch will save bandwidth. It will, when it is not sending it on these ports, it is saving the bandwidth by not unnecessarily congesting it by sending it across these three cables. And also, since it is not sending it to these, PC1, PC2, and PC3 will save their CPU cycles, since they will not have to process the frame, because every frame they receive, they have to check whether the frame matches their own MAC address. Okay, so they are saved of this CPU cycles effort, pending CPU cycles effort also. Okay, so that is what it is. So the key takeaways for the concept of filtering. Switch filter the frame if the DA of the frame resides on the same port on which the frame was received. In our example, destination D was also residing on the same port P4 on which the frame was received. And as explained, switch helps save bandwidth and CPU cycles since it filters the frame PC1, PC2, PC3 did not have to process the frame. And likewise, the cables would utilize the bandwidth for some other interesting traffic. Okay. So up until now, we had the flow chart like this. We had a two-step process where the first step was to check the source address field. If the entry was not there in the MAC table, make an entry. This part was known as learning. If the entry was there, we would refresh the value, aging, dynamically learned entry, reset the aging, whatever the value of the timer was, reset it to 300, and then move to the step 2, check the DA value of the C frame. Okay, and if the MAC table had the entry, did not have the entry, then we would flood the frame. And if it had the entry, we were forwarding the frame. But now that we have learned the concept of aging, this step is further expanded. And then we start checking the corresponding port also. So check the port number associated with the MAC. And if it is not the same port, then forward the frame. And if it is on the same port, then filter or drop the frame. The next lesson, we will go over questions related to flooding, forwarding, and filtering. These will be scenario-based questions. And again, in practical interviews, when you are live in front of a panel, appearing for interview in a company, this is how question get asked. So we'll go over questions related to flooding, forwarding, and filtering.